So today we're talking about congruent figures. How to identify their congruent parts, how to name them, how to recognize from the name what parts are congruent. We're going to talk about all those different things. Okay? We're setting up the basis, the groundwork for writing proofs to prove that triangles are congruent. But before we can do that, we have to understand what congruent means. Okay? So, recognizing congruent figures, identifying corresponding parts. See, there's another use for the word corresponding. Corresponding angles so far means when lines are parallel, corresponding angles are congruent. Those corresponding angles are in the same position. The reason I gave you the definition in the same position is that's what it means here too, but it's not with lines. Okay, it's with figures, other figures. So here we have two figures. Okay? Take a minute, try to draw them best you can to look the way they do. And then we'll talk about what this means, okay? Let's talk about what this means. First of all, this symbol right here, that symbol means congruent. It's an equal sign with actually a similarity symbol over top of it. It means congruent. Okay? This is saying that ABCD is congruent to EFGH. Since it's not a triangle, since they are not triangles, we don't use triangle symbols. And so if they have more than three sides, we don't put any symbol out in front of them. We just list them. So when I name this, I'm starting with angle A. I'm going A, B, C, D this way around. Okay? And on the other one, I'm starting with E, and I'm going E, F, G, H this way around. Okay? The point I'm trying to make is when they name a figure like this and they say they're congruent, they're telling you that this is the way they match up. So the angle that's corresponding with angle A is angle E. The angle that corresponds with B is F. The angle that corresponds with C is G, and the angle that corresponds with D is H. Okay? So those are corresponding angles in this case. So what side corresponds with segment AB? What's that? EF. That's correct. Segment AB corresponds with segment EF. So segment AB is congruent to segment EF. Which segment, let me move some of the stuff out of here. What segment corresponds with segment AD? EH. Okay? Segment EH corresponds with segment EH corresponds to segment AD. Okay? Is that making sense? I asked that wrong, I'm sorry. I don't really want those who get it to respond to this. I want to know if anybody in here still is not understanding what I'm saying. So the real question is, does anybody in here need more of those to think about, to talk about before we move on?
Question.
Okay, go ahead, Paul.
So if it's so AC would go with EG.
It would, but AC is not a segment in this case, it's a diagonal.
Okay, I see.
But you're right, the diagonal AC would match up with EG, segment EG. Okay? So you see the order in which these letters are labeled matches up with the order in which these are labeled. So you don't need to draw the picture to know what parts are corresponding, what parts are congruent. If you know the two figures are congruent, then these corresponding parts are congruent. And that leads us to this right here. Corresponding figures. All corresponding parts are congruent. All corresponding parts are congruent. So the corresponding angles are congruent, the corresponding segments are congruent. And like Paul pointed out, the corresponding diagonals would be congruent. Okay, I'll pause that while you finish copying it down. So as we move on, this says triangle. Notice the symbol, triangle symbol. If there's only 3 letters there, if it's only a 3-sided figure, it's a triangle. And we have a symbol for that, so we actually need to use the symbol. Don't just call it ABC. If you're talking about the triangle, you say triangle ABC.
Is that next one a triangle too, or a D?
Yeah, it's a bad-looking triangle. I can try to clean it up a little bit. That's a triangle symbol also. Triangle. Triangle ABC is congruent to triangle EDC. Okay? Now the reason I want to point this out to you is because I want you to know how to label your picture. So I'm going to put this mark here, and this mark here. Okay? In your group, talk about where the 1 arc, 2 arc, and 3 arcs go in the other triangle based on the name. Okay? Go. Hannah, would you please, before you erased, would you tell me how many arcs did you have right here? 2? Like that? Okay. And Noah, could you voice what you said to Hannah?
I said when E only have 1 because between A and 2.
Okay. I think he was pointing to this and saying, wouldn't E only have 1 arc because A only has 1 arc? And when you look at the name, the A is the first letter and the E is the first letter, so that means they do what? They correspond with each other. They match up. So he is exactly right. And Hannah realized, yeah, that makes a lot of sense. So she erased that and put 1 mark there. Okay? So Megan, what did your group say about the 2 marks? Which letter is that? D. I agree. Because B is 2 and it's the second one. And so D should be 2 because it's the second one. And then C. Okay. Now, do you realize we cannot call this angle C like that? We cannot. We can label it angle A. We can label it angle B. We can label it angle D and angle E. But we can't call it angle C. Can anybody tell me why? Nick?
Is it because A and B are the ones that connect to C?
That could be. You said, is it because A and D are the ones that connect to C?
Like that angle line. So it really, C doesn't really have its own angle.
Ah, there you go. Now you're talking the right terms. If he looks up here, he sees that A is all by itself. There's only 1 angle there, isn't there?
Yeah.
So we can say that angle A is congruent to angle, sorry, E. My bad. You didn't see that at home. I still almost put a C there instead of an E. Okay? So it looks like that. So angle A is congruent to angle E, and angle B is congruent to angle D. But we can't say angle C is congruent to angle C. We can't do that. And that's because there's too much going on at angle C. So if we say angle ACB, see that? Then what do I say that's congruent to? ACB. Louder, please. ECD. Let's check it out. ACB, ECD. That's correct. It's the same mark we made, wasn't it? So angle ECD. Okay? Very good. Is that what you're going to tell me also? Nice. All right. Any questions on that? Okay? Now, what I want you to do, I'm going to tell you that segment AB is congruent to segment ED. How many sides does each triangle have? 3. I've listed one of the pairs of corresponding segments. I want you to list the other 2 pairs. Talk in your groups about that and tell me what goes here and what goes there. Okay? Oh, shucks. All right. We're recording again. Kaylee, what did your group say number 2 was? Your group didn't find an answer? Taylor, what did your group say? BC is congruent to DC, you said? Did anybody modify that just ever so slightly? Everybody put that exactly the way it is? What did you say? Segment. Yeah, it would be more appropriate. Remember, without the symbol, it means the distance from B to C, and distances are equal. Figures and shapes are congruent. And so we want to say these segments are congruent. Okay? And the third one, go ahead, Paul.
Segment AC is congruent to segment EC.
Okay. Segment AC is congruent to segment EC. Okay? So that is correct. Now, how many corresponding parts did I get for those 2 triangles? How many corresponding parts did we get for those 2 triangles? I heard a 3. I heard a confirmation 3. Did we get any more than 3? Now I'm hearing a 6. And I'm hearing a confirmation of 6. In fact, they said, I think 6 would be better. Those who are saying 3, you're looking at 3 what? 3 segments that we just numbered 1, 2, 3, right? But what have we already done? 3 angles, hadn't we? So there's 3 angles and 3 segments, so there's a total of how many corresponding parts? 6. What if I, instead of had triangles, what if I had quadrilaterals? I had 4 sides. Then I'm going to have 4 angles and 4 sides, giving me 8 corresponding parts. Part of your homework today, you're going to be recognizing what parts are corresponding, what parts are congruent, and they want you to list all of them. Okay? All of the angles and all of the sides. So if 2 angles of one triangle are congruent to 2 angles of another triangle, then the third angles must be congruent. This is a theorem. This theorem doesn't have a name, but it's a theorem. What does every angle of a triangle always add up to? 180. So if the first 2, and I should have had not a single arc mark, I should have had 2 on one of them and 1 on the other. But if the first 2 are 130, so they add up to 130, then what does this third angle of the triangle have to be?
40.
Or 50, right? 50 plus 30 is 80, and plus 100 is 180. So if these two are 130 also, then it has to add up to 180. This one also would have to be 50. So it makes sense, doesn't it? If two angles of a triangle are congruent to two angles of another triangle, the third angles have to be congruent. Right? They have to be. Do you think that makes these triangles congruent?
No.
Not necessarily.
They're similar.
They'd be similar. You're right on. We're not officially covering this yet, but what if
One of them's bigger.
I did this?
Exactly.
It doesn't change my angles, does it? Oh.
No.
Well, that's okay. I'll move that out of the way. It doesn't change my angles. Now, are they congruent? No, they're not at all congruent, are they? The angles are still the same, but the three sides are not the same length anymore.
That's what.
Okay? So just being three angles congruent doesn't give me two congruent triangles. Anybody not finished copying that down? Okay, let me pause this while you finish. Okay, here we go now.
Sparked the debate.
Your assignment today is 1 through 27 all on lesson 4.1. Okay? 1 through 27 all on lesson 4.1. Yeah. Yeah. Now remember,